Welcome to my project bazaar.com. Spine segmentation in medical images using manifold embedding and high order MRFs. In our development, segmenting the spine shape medical images using efficient techniques, using MRF Markov random field clustering to obtain the global data and shape coherence in manifold space of spine models. The different shapes of the input images were previously saved and the shapes can be matched with the input images where which the shape it perfect and then finally the segmentation images that which shape perfect and finally segmentation can be employed. The modeling of 3D shape and matching of shape in the image in 3D were not possible in MATLAB. The 2D images can be used as input and clustering is employed using Markov random field model. Markovian models of images maybe help us to make better image restoration, the enhancement and segmentation. However, using segmentation methods based on Markov random field models requires a huge computing power and quite a lot of time. For these reasons, the MRF model methods are usually used in O-line tasks, never in a real-time pre-processing environment. Recently, multiprocessor arrays, transmitters, and a distributed computer system have been used for MRF processing, but all of them are power consuming and still slow considering the standard video rate. This is the flowchart of our process for spine segmentation technique using MRF. First of all, we have to take the 2D spine image. In this segmentation process here we have to take the medical spine images and to add the noise to the input image to improve the quality of input image. Gaussian noise should be added to the input image for medical spine images. This step of beginning the manipulation the input image for obtained for the processes of segmentation and registering the process. The next process should be the clustering process. This is an important process to input medical spine image and then to registering that image using the medical registration method from segment the spine image normal registration method to follow the after the process of MRF clustering to segment and register the input image for to specify the retrieval process of the original medical image, and then another model is retrieval. The retrieval of original image after the process of segmentation and registering the image. In this model, we have to calculate the distance between train values to the total number of images in the dataset. From calculating the distance, it's easy to retrieve the output image process after the segmentation and registering. This final process is to calculate the performance of our model. This calculating distance is to measure the minimum distance from the calculated distance between the train and the test value. This is very easy and efficient process to retrieve the output medical spine image. The performance to be calculated from the output image to be efficient. This is the MATLAB main window. In that main window we have to execute the file from the current folder. This is the command window. Whenever you run any coding in MATLAB, it should be run the execute on the command window. This is a workspace. In this workspace we run the variables, values and functions on our coding. The command history is nothing but using all values and variables in the command windows to be stored in history, as history in that command history. Choosing that GUI main.m file, then right click run file. This is the window, the main window. This is the main window of our process to run the spine segmentation in medical images using manifold embedding and high order MRF Markov random field. This is the buttons or the input image, noisy image, registration and retrieval of image. This is a steps of our process, such as follow the procedure flow chart. Choosing the input image. Then after clicking the input image, we have to the display for choosing the input image for us as spine medical image. I choose the file 1. Click open. Then click the another button, the noisy MRF image. After clicking the noisy MRF image, the code should be run in the process of 1 to 26. Now we have to execute the output the noisy image in that second axis. This is after clicking the noisy image, we have to click the registration button. After clicking the registration button, the program should be run in that command window. The command window is to be run off till 100. After running the command window, we have to execute our process the registered image. Only the spine parts of input images to be registered in that image. The segmented is possible in that MRF process. After the final process to be retrieval of image, the retrieval image should be the perform the passive indoor process to take input such as noisy and registration process. After clicking that, the retrieval process is to be processed 100th iteration. After we have to retrieve the image in that window. This is the final output of our process. Now we have to conclude our process to take a input image and to execute the noisy image. The noisy image to be run in our process. Then after noisy image, we have to register the image using the MRF Markov random field segmentation technique. After segmenting, we have to retrieve the final output to calculate the minimum distance between the dataset and classification technique. Thank you. Have to calculate the distance values between 2D spine input images and trained values. From those values, we have to compare the separate minimum values from those and even check the perfect match to the original images in the database. Finally, those perfect matches outputs from to segmented from their image performance to be measured. They conclude the process to the spine medical images can be clustered using Markov random field method, and from those shape models to obtain the registration based segmentation model. Check the perfect match from the previously saved images in the input images that which shape is perfect, and then finally the segmentation can be employed. Finally, the 2D images can be used as input and clustering is employed using Markov random field model to be obtained modeling of the 2D images. Thank you.